So hi everyone, welcome to our fourth Python data and scripting webinar session. So this is our final session in this series, and thank you for joining us so far. We have some more exciting Python to learn tonight. So tonight we're going to be going over a Python library called Pandas, and then we're also going to be learning how to do some data fitting using a library called SciPy. So that's what's on the schedule for tonight. And so I'm going to go and open my Jupyter notebook, actually have it open, but I'll just remind everyone of how to do that. You can click on the Python data and scripting tab, and then you can open the Jupyter notebook from there. And I'm actually going to open it in a new tab. And then I will launch my notebook. All right, so I am in my Jupyter notebook, and I will zoom in. So I have opened my Jupyter notebook application. I'm looking at my data well, there's a folder called data, and then I have my MolSSI workshop folder. So I'm going to click in my MolSSI workshop folder. And I went ahead and did this. We did have a starting notebook for homework 3 for you. So I'm just gonna go ahead and open that and talk about what the assignment was for homework 3. So this is the starting notebook for homework 3. And for homework 3, what we wanted you to do was we wanted you to start from the code that you wrote for your first homework. And we wanted you to modify that code to make it a little bit better. So the first thing that we wanted you to do was we wanted you to change your code so that instead of just saving these values to a list, you were writing the values to a file. So that was the first thing we wanted you to do with this homework. And that is outlined here on number 1. The second thing we wanted you to do with this homework was to take your code and put it in a .py file so that you could run it from the command line. And then it also says to make your command line script, use a user input for the file name. And I did link you to sort of online materials where you could see information about how to do this. So the lessons that we've done relating to these topics. But that was the homework. Okay, so I'm going to show how to upload files to the Jupyter Notebook on NanoHub. So I'm going to go to where we had the starting notebook for homework 3. And there's a link here that says download the starter notebook. And so I am just going to click on that. And then I'll save the file. Okay. So once that file is saved, I'm going to go back to my Jupyter Notebook tab. And then I'm going to click the upload button. Then after you click the upload button, you're just going to choose a file to upload. So probably homework 3 is going to be the first one that you have. Well, what you'll need to do is go to your downloads folder and then look for homework 3, choose that, and then upload it. So I could do that. I've downloaded homework 3 several times, so I'll choose it, and then something will come up and look like this. You can change the file name if you want, but when you want to upload, you click this upload button, and then it's going to upload it for you, and it will be on the Jupyter Notebook, like in your Jupyter Notebook on NanoHub, and then you can click on it and edit it. So that is how you upload files to NanoHub. Okay, all right, so now I'm going to start with my homework, and we have 2 different things that we want to do. You could do these, like, doesn't really matter which order you do them in, but I'm just going to do number 1 first. So the first thing that this wants me to do is to save the values in integers in a file called etot.txt. And then it also tells me that each value should be on its own line. So I'm going to go here to my solution, and I'm going to do something called refactoring my code. And Dr. McDonald mentioned this last time. So I'm starting from some code that exists already, and I'm just changing it a little bit. And previously, what I did was I had this empty list that I created called energies. And then I had a for loop where I looped through each line in data, which data was the data that was in the file that I opened. Then I split the line. So I split the line into different words. Then I got the number associated with the total energy. And then I appended that number to a list. I can leave in this list if I want. So when I write the file, one thing I can do is I can just add another statement here where I write this number to a file. So I think that that is what I'll do. So if I want to write to a file, the first thing that I have to do is I have to open a file for writing. And I'm going to create a file called output. Well, I'm going to create a variable called output. And I have to open a file for writing. So I'll open, and then I give the file name, which my file name was etot.txt. That's what I want my file to be called. And then I'm going to go outside of my quotes. I'm going to put a comma. And then in quotes, I'm going to write W plus. And we covered this in our file parsing lesson, but what W plus means here is that we want to write to the file, and if it doesn't exist, then create it. So here, when we opened this file, we used an R because we opened it for reading. Now, when we want to write to a file, we're going to use a W plus, and the W is for writing. So I've now opened my file etot.txt, and I have opened it for writing. Okay, so now that I have my file open, now I need to write to the file. So I'm just going to put my cursor here at the end of my energies.append, press enter so that I'm on the next line, and then I'll write output.write. And then in parentheses, I'm going to put what I want to write to the file. I'm going to use my F string here. So I'll put a big capital F and then quotes. And then in my curly brackets, I'll put the name of the variable that I want to write, which what I want to write is number. So I have a number here. So I'll write number. So all I've added so far is I've added this file, this line where I opened a file to write to, and then I added a line where I did output.write. So I opened the file for writing, and then I'm writing to the file, and this is going to be written to every time we find etot in a line. And then if I write to a file, if I open it, I have to make sure that I close it. So at the end, I need to, well, I'll be at the end of my line. I can press enter again. So I'm going to press enter twice, and then I'm going to press backspace twice to get out of the loop. So the first backspace took me out of my if statement, and the second one is going to take me out of my loop. So we want to write, or we want to close the file once we are done with this for loop. And we know that we're done with this for loop when our cursor lines up with the for loop. So that means to do it after the for loop is done. And so I'll do output.close, because if we open a file, we have to close it. So we've had a question in the chat. Output is the name of a variable, and the name of the file is etot.txt. So the file will be called whatever you put here in quotes when you open it, and the variable is called output. So output is something that you can think of as representing the file, but the file name is going to be etot.txt. Okay, let's try executing this. Okay, so the first thing that I see is that this ran and I'm not seeing any errors, which I am happy about. And then after I run it, the next thing I want to do is I want to click over here to my MolSSI workshop tab. And then I'll see that I have a new file here called etot.txt. It says it was last modified seconds ago. And then I probably want to open it and look and see how it looks. Oh, okay. Looks like I made a little bit of a mistake here. Does anyone know sort of what I missed doing or what's wrong with my file? So I've just written everything to my file and it's all jumbled up together. Does anyone have any ideas? Yep, it's out on different lines. So it all wrote it to like one line. So the way that we fix this is we have to remember that when we write to a file, we have to tell it that we want everything. We have to tell it when we want everything on different lines. And so we have to put a special character here. So I'm back in my Jupyter notebook on my write statement. I have to put a special character. Yep, that's exactly right. And that is /n to tell it to put it on a new line. So that is the new line character. So I'm going to add that back. I'm going to add that in, and then I'm going to run my code again. I'll close this and then open it again. And that looks much, much better. Okay, so we did number one. So the first thing that we did, and this is just to show that if we have several things we want to accomplish, we can do them one at a time. So we did the first one. We now have modified our code so that it writes to a file. So now let's do the next part. And the next part was that we wanted to create a command line script. So that means that we have to put this in a text file, and the text file has to end with .py, and then we can run that Python file from the terminal. And then after we have it in a file, in a .py file, we want to change it so that the user can specify the name of the file. So that's similar to what we did last time. We don't want them to have to go in and edit this. We want them to be able to put it with the script name. So I'm going to go to my cell. I'm going to highlight it, and then I'm going to copy it to my clipboard. Then I'll click back out to my MolSSI workshop folder, and I'm going to, this time, select new and then text file. Okay, so once I'm in my text file, I'm going to paste what I have copied. Then I can give this a better name. I'll call it homework 3. And then very importantly, it needs to end in .py so that Jupyter knows that this is a Python file. Otherwise, it's going to think it's just a text file. And then once we have it ending in .py, you'll notice that the colors changed on my text. So now it's doing some color coding for me. And something that I also like to do in my .py files is I like to, on the very first line, I do like 3 quotes. This lets you write a multi-line comment. I think Dr. McDonald showed this to you with doc strings when she was talking about how to write documentation for functions. But I usually write like a 1-line description of what this is. So this is similar to like your markdown cell that you'll always use when you're using the Jupyter notebook. Okay, so this is the solution to homework 3, and then all we did was copy and paste what we had already. So I am going to save that, and then I'm going to test it to make sure that it works, because every time I do something, I kind of want to make sure that it works before I move on. So I'm going to go ahead and open a terminal, and I'll do new terminal. So one thing you may remember or may not remember is that when we start our terminal, we're actually going to be in our first folder, like the first folder that's opened. And we learned a few terminal commands last time, and these are just commands that we can use to let the computer know what we want to do. So one of those was ls, and ls is for list. So if I do ls, I'll see that I have where I am right now, I have two folders, one called data and one called MolSSI workshop. So before I run my script, I need to be in the MolSSI workshop folder. So I'm going to have to change directories to MolSSI workshop. And the way that we did that was cd. That's for change directory. And then we had to type the name of the directory that we wanted to change to. So I can type MolSSI workshop. But a real trick that you might find useful is that if you start typing it and then you press the tab key, it will fill in the rest for you. So I'm just going to cd MolSSI workshop, and then I can check and make sure that I'm in the right folder. If I type ls again, I should see homework3.py. And then I'm just going to try running it. So I'll type I'll type Python, and then the name of the file I want to run, which is homework3.py. Again, you can try using your tab button, your tab key. It will go as far as it can, and then you might have to say 3.py. And it should run without any error. So I kind of don't like the way that this doesn't tell me anything when I run it, so I'm going to change it a little bit. I'm going to go back to my homework3.py file, and I'm going to add some print statements just so I feel like something's happening when I run it. I'm going to add a print statement here under where I opened up the file. This is just a fun thing to do. So I'm going to say print, and I'm going to print something using my F string. I'm going to print the name of the file that I'm analyzing. So I'm going to say analyzing, and then I'll do my curly brackets, and then I'll fill in the file name. And that's just so I feel like when I run it, I'll be able to see that something was done. So I'm just putting in a line that says analyzing file name. And then at the end, I'm also going to print something that says done. Okay, but let's get to what our homework assignment was. So we've done part of our homework assignment. We put this in a .py file. And then the next thing that we asked you to do was we asked you to make it so that the user could input what this file name was. And in the last class, the way that we learned how to do that is with with a library called sys. And within that sys library, there was something called argv. And we could use argv to get information from what they typed on the command line. So we're going to, we'll add that. And so to add that, we're going to add an import here. We'll do import sys, because that's the library that we want to use. And then I'm going to comment this out because I don't want to completely get rid of it, but I'm not going to use it anymore. And then I'm going to write file name is equal to, and then I'm going to use that sys.argv. And last time we learned that sys.argv is a list that has information about what was typed when we ran our program. So I'm going to pop back out here for a minute. So for sys.argv Python, it's a list. Python is in index 0. The name of your script is in index 1. And then if we have something else that we're adding, it's going to be an index 2, like a file name. So if we want someone to write Python homework3.py and then the file name that they want to analyze, the file name is going to be in sys.argv, and it's going to be in index number 2. So now we're expecting the person to put in the file name. And that's all we have to change actually now, because we've used this in a variable, and then that file name will be opened, it will analyze it, and then it will write the file. So let's try that out. And I'm just gonna go back out, before I go to my terminal, I'm going to go back out here to my MolSSI workshop folder, and I'm actually gonna delete my etot.txt so that I know that it's being written. And then I'll go back to my terminal and try running this again. So I will type Python homework3.py. And if you were wondering how I'm typing that so fast, remember, try typing part of it and then using your tab key on your keyboard. It's really useful. But now we type data, and then we type O3 underscore PROD dot MD out. And then I will press enter to run my script, and hopefully it will work. Oh, I don't see it that it says done, so I'm a little confused about that. Did I print done? But I just ran this with the file name. It told me it was analyzing it. And then I can go back over and check my file. There it is. And there are my values. Are there any questions while we're waiting?
There is a question in the chat, Dr. Nash. Someone got a list index out of range error.
Okay. So there are a few things that we need to, so some things that might happen. So for example, if you just type, so list index out of range means that you have a list somewhere and you've put those brackets, and then you put a number that is larger than the number of elements in the list. So the place that that's most likely to occur is on your sys.argv line. And did you remember to type the file name after homework3.py? Because I'll show that if we don't type a file name here, I think I should get an error here, so I'm a little confused. I'm going to make sure that I actually saved my homework3.py. Save. Okay, now let me try running it again. Maybe I ran. All right. Okay. Now I'm getting the same error. Maybe other people got this error too. Did I type? I think I might have miscounted. So actually, it might not count the word Python. So maybe it starts 0, 1.
I believe that is correct, Dr. Nash. I believe it starts counting after the word Python.
Okay, so I made a mistake there. I put, it should have been a 1 here instead of a 2. So if you were having trouble with that, changing that to a 1 should help. So let me go back so everyone can see what I did. So I made a mistake and I miscounted on my list. It should be sys.argv1 instead of 2. And I had forgotten to save. I know that when Dr. McDonald was teaching, she saved several times just to be careful, and I forgot. Great. There is one final thing that I wanted to cover that was not part of the homework that I think would be really useful for this script we're writing, and that is I kind of see a problem with this script, something that would make my life harder if I were using it, because the idea is that if I go to my terminal, I can type any file name here. So if I type, we have a folder called ndout, and I think we have some files in there, and I'm just pressing my tab key to see what is in the folder. So for example, if I want to analyze this one, poly AT-GB ND1 12A cut.ndout. So does anyone sort of see what could be difficult or maybe a problem? Thing that I'm thinking of is that our output file always has the same name. So if I wanted to analyze several files, then I'll probably have to rename them, or I'll have to move them before I run my script again. So what we could do, there are a few things that we could do. One thing that I can think of is we could let the user specify the output file name also. So if we wanted to do that, we could have another variable that was something like, yes, it is always writing the same file name. So if we want to analyze several files, it's going to overwrite the same one every time. And there are a few things that you could do with that. One is that you could use a variable file name. Remember when we were creating our plots, we did a variable file name. That one is a little bit more complicated for this case, because you probably want to, in the lesson materials, there's information on how, if you're giving a full file path, you can just get the last part of it. So if you were really writing this for your research, you'd probably want to do something like that. You can also make it so that they give you the output file name. So I'll show how to do that. So let's say that we wanted them to type the output file name. We could do something like output name equals, let's say that we expect them to type it after the name of the file they want to analyze. So that one would be 2. It'd be the next element in the list. And then here, instead of etot.txt, we would make it into our f string, and then in our curly braces, we would put the output name. And then we can save it. So I've just made 2 changes here. I created a variable called output name, and I've set that equal to the next thing that the person types. So they're going to type Python homework 3, the name of the file to analyze, and then the name, the output file name. And then I made it so that is the file that I open. Here on this line where I have my open for writing. Okay, so once I've made those changes, I'm going to save the file. And then I'll just show what that would look like. So I'm actually going to clear my screen so that it's a little bit easier to see. If you want to clear your terminal screen, you type the word clear. And then I'm going to type Python homework 3.py. Then I will type a file to analyze. And actually, I think I'm going to use that trick Dr. McDonald mentioned last time, and I'm going to hit my up arrow 2 times. And now this time I will give an output file name. And I could just name this something so that it's not the same every time. So I could call it poly AT-GB ETOT. You could call it anything that you wanted. And now when I go back here, I will see, I'm going to sort by last modified. I'll see that I have that variable file name instead of just the tot.txt. Okay, so now we are going to move on to our first lesson. And for our first lesson today, we are going to be learning how to use a Python library called Pandas. And Pandas is one of the most widely used libraries in sort of Python for data science. So it's a very, well, Python and Pandas and NumPy. But Pandas is really good for, say, exploring your data, and Pandas is really good for data that has mixed types. So that would be words and numbers. But yes, very, very important, used a lot for data science. So just like NumPy, Pandas is going to be the most useful when we have data that is tabular or data that is in rows and columns. And we do have some new data for you to work with for this portion of the workshop. I'm going to be sending a link. So I should have included this in your lesson materials, but I left it out on accident. So I want everyone to create this file in their workshop folder. You can just put it in your MolSSI workshop folder. We don't need to put it in our data folder. But if everyone can click the link, and then probably some people need it on the NanoHub group. So let me post it there. I guess as long as we can all see what I'm doing and we all do it the same way, it will be okay. So you can click, if you go to the group, if you need it, like if you're on your computer and not on the Zoom meeting, if you go to the group that will be stickied here at the top, you can copy that and then in your browser, paste that. And then it will open up this text file for you. So I am going to, so you can do something like select all of it and then copy it. Then if you go to your MolSSI workshop folder and do new text file and then paste it, and you can change this file name to pubchem elements all.csv. That is the name of the file. So that's one way to do it. And the thing that Dr. McDonald said that's pretty smart is just to do file, save page as. But I think that might have the wrong extension, but we'll just do pubchem element. So that will save it with the correct name in your downloads folder. All right, it will save it with the right name, and then you can use the upload button. So that is another way to do it. I hope that wasn't too unclear. Okay, we actually need to do this with one more file. So I will paste that. So we need to upload one more file, and I'll make another announcement for that one. Okay, so I'll go back to the NanoHub group. You should see a second file. So I'll copy that. And I'm going to do the thing Dr. McDonald said because I think that works better. So I'll do file, save page as. Now I'll save that to my downloads folder. And then I am going to upload that. I don't know why sometimes my downloads don't all show up. There we go. Datafitting.csv. Okay, so now I should have a pubchem elements all.csv, and a data fitting.csv. So I'm going to close these other windows that I have open because I don't need them. And make sure I have this saved. Okay, and the next thing that, okay, now that we have our data that we're going to read, we are now ready to use the Python library pandas. And before we use pandas, I just want to take a look at what is in pubchem elements all.csv. And what this is this is a file that gives us information about all of the elements in the periodic table. And if we look at this, we see that we have a list of numbers. So here we've got some numbers. Here we've got some words. So we've got atomic symbols, the word helium, we've got numbers. And you'll also see that all of these values are separated by commas. So by CSV, it's a comma separated value file. And if you think about the way that we would read this in using methods we already know, it would be pretty complicated. But luckily, since people do so much data science these days using Python, there are some really good libraries to read files like this. And one of those is called Pandas. So in this next section, we're going to be looking at how we can use the Python library called Pandas. So I'm going to create a new Python 3 notebook. And once I'm in my notebook, I'm going to write myself a note in my markdown cell. So I'll put the hashtag and then I'll write Pandas Lesson. And I'll write something like learn how to use Pandas library. Then I want to make sure that I give my notebook a new name. And I'm going to call it Pandas Lesson. Okay, so now I have my Pandas Lesson notebook. Okay, so if we want to use the Python library Pandas, the first thing that we need to do is import it. And to import Pandas, we type import Pandas, and then usually people will import Pandas as PD, so they don't have to type Pandas all the time. Then I can execute my import statement. It should run pretty quickly. And if you don't have an error, then you have imported Pandas. The next thing we want to do with Pandas is we want to use it to read our file. So we just put that file in the same folder as the one that we're working in. So we don't really need to build a file path. But the file that we're going to read in was that pubchem elements.csv file. And I'm going to create a variable called periodic. And that is what I'm going to use to read in my data from that file. So we're going to be using a function in Pandas to read our CSV file. And the name of that function is read CSV. So the function does exactly what it sounds like. So we'll say pd dot read CSV. And then we're going to put open close parentheses, and then in quotes, we're going to put the name of the file we want to read. And we said that we wanted to do pubchem elements. So this should be the name of your So we are going to use the read CSV command in Pandas, and then in quotation marks, we put the name of the file that we want to read. And this is a function for reading CSV files. Pandas also has functions for reading Excel files and some other file types also. So Pandas can read CSV files, and it can also read Excel files if you have those. Then after I have that typed, I can press Shift Enter, and Pandas will read in my CSV file for me. So Pandas is really nice. It's really good. I think that it's really good for reading in CSV files. I think that you might agree that it's a little bit easier than some of the other methods that we've learned so far. And so let's see what Pandas read from our CSV file. So I'm just going to type my variable name and press Enter so that it will show me what is in this variable. And so when you do that, you should see this very nicely formatted table that Pandas did for us. So this is what Pandas did when it read the read CSV file. So you'll see this top line here is a sort of our headers. So this is kind of what you see when you look at a spreadsheet. But we have headers here. So it's taken the first row of our data and made it into headers. We have atomic number, we have symbol, we have name, atomic mass, and then it filled it into a table for us. So right now it's showing us the first 5 lines or the first 5 rows of our data. And you'll see it's highlighting what parts we're over. And then these 3 dots mean there are a lot of entries in between, and then it's showing us the last 5 rows of our data. At the end, it tells us that it read in a CSV file, and it had 118 rows and 17 columns. So this is a really nice way to kind of look at data if you have it in a CSV file. But isn't this cool? Isn't Pandas exciting? Pandas is one of my favorite Python libraries.
I was just about to tell everyone that Pandas is one of your favorite Python libraries. I have to say, I was not really a Pandas believer before I was friends with Dr. Nash. I was like, no, NumPy is fine. Why do you need to learn Pandas? But Pandas is super good anytime you have like data that has different types, like some data that's, like a word, and some data that's like a number. It's really, really great. And learning Pandas is currently an incredibly popular job skill. Like lots of jobs in data science, you need to have proficiency in Pandas. So it's a really important library to learn.
Right. And say if you're doing our fundamentals of deep learning, they'll use Pandas a lot in that workshop. So there are a few methods that you'll see in, and so I want to leave this here in case people need to see it. So I'm just going to show you a few methods that you can use in Pandas, and I'll start in this cell. So there are a few cool functions that you can use in Pandas that will tell you a little bit about the file that you just loaded in. The first one that you see a lot is called the head function. So it would be the name. So this variable that we have now, people will call it a data frame. That is the data type. So for NumPy, the type is NumPy array. For Pandas, the type is something called a Pandas data frame. So this variable periodic, its data type is a data frame. And if we use something called dot head on our data frame, then it is going to show us just the first 5 rows. And this is a function that you'll see people use sometimes to kind of just check what is in their data frame. There's also a scroll bar here, so we can scroll and see more of it if we want. So that shows us the first 5 rows. The second function that people use sometimes is called tail. So it would be periodic.tail. And that is going to show us the last 5 rows. So I'm going to type a comment here. I'll say, look at first 5 rows, and dot tail is the last 5 rows. And then the other really useful function that you can use, well, there are 2 more useful functions that you can use. One that I really like is called describe. And I'll just put my comment here. And what describe is going to do is get statistics. So I can do periodic dot describe. And then open and close parentheses. And when I do periodic dot describe, so I'll go ahead and execute that. It's going to give me a table where it looks at every column and it decides which one of those are numbers. And then it's going to give me the count on each one. Then it will give me the mean or the average for each column, along with the standard deviation, the minimum value, and then information about the 25th, the 50th, the 75th percentile. So this is just something to give you really quick, if you have something in a data frame, if you got something in a CSV file, or you can, like I said, load something that you have in an Excel file using Pandas. And that's just a different function. It's called like read Excel instead of read CSV. And if you want to get some really quick, sort of really quickly get the average and the standard deviation of each column, then this is a way that you can do it. It's just this function called describe. So one thing that you'll notice when you look at your table that comes out of describe is that it is only giving you values for, if we look up at sort of our data, it's only giving us the mean for columns that look like numbers. So it can't give us the mean of like this symbols column because these are all words, same for name. So one thing that Pandas does is that it guesses what the data types are. And sorry, I just saw the question. I just saw a question in the chat. So we don't need to paste links to the terminal. If you need to paste something, if you need to get those files from NanoHub, you want to paste it in your URL bar. So yeah, I'm gonna demonstrate that. So if you have one of these copied, copy it, and then you can open a tab and paste it here. And that's where you'll want to paste it. And then you get the data from there. Then once you're on this page, you can do File, Save Page As, and that will download the CSV file for you to upload. So I hope that helps. And if you can't do Control-C and Control-V, then I would, and if you do really need to paste something to the terminal, maybe just right-clicking would work. Okay, so that is using the describe function, which I really like because let's say I just need the average of every column. I can just use describe and get that. That's getting the statistics, and I want to emphasize this again. We can see the data type. So remember, Dr. McDonald and I have talked a lot about data types. So if I do periodic.info, that's going to tell me the data type for every column. And the really nice thing about Pandas is that when it reads in the data, it looks at what's in each column and it guesses what the data type is. So it has looked at the atomic number column and it has decided that's an integer. And then it looked at the symbol column and it just decided that was an object, but really that means string. So it decided that was a word. And you can see sort of what it decided each one was. So there were certain ones where it decided that it was a floating point number or a decimal number. So that was atomic mass. Electronegativity, it decided was a floating point number. And so the next thing that I want to point out is this column called non-null count. So that means that's telling me how many cells have values in them. So for example, like let's look at this column called electronegativity. It says there are 95 non-null values. So that means that there are 95 elements that have electronegativity values. Not all of them have values for electronegativity. You might have also noticed, if you were looking here, like at the end, you'll see here NaN, that means not a number. And Pandas just fills that in if there's no value. Yeah, that just means that there is no value in that cell. So for example, for moscovium, we don't know what the electronegativity is, and it's not part of this data set. So it just put NaN here because it is not a number. So that is just something to know about sort of the way Pandas works. If you see this NaN, that means that there is no value. Okay, so that is all really helpful. So we can really easily see statistics using Pandas. We can get info about the data type. The next thing I want to show you is how we access information in a Pandas data frame. So I'm going to make a little markdown cell here, and I'm going to do 2 hashtags for a subtitle, and I'm going to call it accessing information. And so if we want to access, and I would just want to look at my data frame again, so I am going to type periodic.head. And there are 2 main ways to access information in Pandas data frames. The first way is by using row and column numbers. And the second way is by using row and column names. So we're going to go over using numbers first. In Pandas, if you want to access information using numbers, get information using numbers, then there is a function that you use called iloc. So for that, I would do, and I'm just going to write this note to myself. So I could do periodic.iloc, and then actually use square brackets here. And then you can put your row index and then your column. So if you're getting information from a Pandas data frame this way, this is really similar to the way NumPy arrays work. So when we were slicing a NumPy array, we gave the name of the NumPy array and then square brackets and then the row and the column. And we could do slicing there. So we could use that colon to get multiple rows or multiple columns. You can do the exact same thing here if you put iloc. So I'm going to show that. So if I want to do periodic, and then I want to get the, let's say I want to get this H symbol. So that would be row index 0, column 1. So I could do periodic, oops, I need to put .iloc, and then square brackets, and then 0 and comma 1. So if I do that, that's how I can get information. I can get the H. I can get a range also. So if I wanted to get row 0 through 5 or something like that, I could do periodic.iloc. I could do my :5. So this is the same as NumPy arrays. And then column 1, then I can get those 5 values. So that is the sort of first way to get information from your data frame. You can use numbers. So this is exactly the same way that we got information when we used NumPy arrays, except that we have this extra sort of word called iloc. Okay, I want you to try to think about, I'm going to give you an exercise. So use iloc to select row 5. So just row 5, and then use iloc to select So take a few minutes here and see if you can figure out how to use iloc to select those things. So what we're doing right now are these two exercises using iloc to select row 5 and then to select rows 30 to the end and column index 2. Okay, let's talk about how you can do this. So for the first one, you probably can't do these both in the same, cell and see them. So I'll do them in 2 different cells. So I'm going to use iloc to select row 5. You can always set it equal to a variable also. So I could do, let's do periodic.iloc. And if I want row 5, I'll put row index 5, and then I'll put a comma. And you can just put a 5, but you can also, if you want to slice it like a NumPy array, we'll put a colon here to tell it that we want all of the columns. So it's going to look something like this, which there was a question in the chat. It doesn't look, so when you select just one row or just one column, it prints it a little bit differently than this table, and you might have seen that here. But if you do row 5, it's going to look like this. It looks different, but it is still a row. It's just printing it a little bit differently when you only have one. So this is what we would expect to see. I'm going to take this next one into the next cell, actually. I'm saying cut, but it didn't actually cut it. Then if we wanted to use iloc to select rows 30 to the end and column index 2, we would do periodic.iloc, and then we could do rows 30 to the end. So if I wanted to do 30 to the end, I would start with 30. And then I would tell it to go to the end by putting a colon. And since I want to go to the end, I won't put anything after the colon. I don't put any ending number. If I put no ending number, it will go to the end. Then I'll put a comma, and then I put my column index, which was 2. And that's just going to basically select the names for me. So when we say how to use 29 or 30, I'm just telling you, you'll have to decide if there's a particular one that you want, so then you have to figure out what that number is. but I'm just telling, when I say rows 30, I mean index 30. So when you're programming, it will just depend on what you want. It's hard to express it correctly because people are always confused on whether I want index or the actual 30th row. But I'll just mean index when I say the number. I try to be clear and put column index, but sometimes it's not clear. The main idea that I want to here is to remind you of is that we can do ranges and that we can put a starting number and then a colon and then the ending number. And if we don't put an ending number, then it goes to the end. That's sort of the important thing. So I think that's all great. But this is all great using iLock is, we can use it to get information that we want. But I think the really great thing about Pandas is that we can use the name of our data to start getting, to access it from the data frame. So for example, I'm going to scroll up here to my table. Let's say I wanted to get the ionization energies from my data frame. So maybe those are the only values that I'm interested in, and I'm not really interested in the rest of this. So if I wanted to get the ionization energy and I had to slice it using numbers, then I would come here, I would look and I would say column index 0, column index 1, column index 2, column index 3. That's not really useful. Maybe I just want to use the column name to get the information. So Pandas will let us do that. So there are some times when you just want to use your column name instead of having to count the columns. And if we want to get just one column information, get column. I'm just writing a note to myself. If I want to get a column using a column name, and then I'm just going to keep writing a note to myself. I put my data frame name, which we have periodic, and then I put square brackets. And then in quotes, I write the column name. And that will give me just one column of information. So if I wanted to get my ionization energy column, I would type my data frame. And then in square brackets, I would put quotes, and then I would type the name of the column, and we have to match it exactly. So this was ionization, capital I, capital E for energy. And that is going to get just the values for the ionization energy for me. And if I wanted to get multiple columns, then you can just put them in a list. So if I wanted to get the ionization energy and, let me get another column name, the symbol, I could type my data frame name, my square brackets, and then another set of square brackets, and then I'll type symbol, comma, ionization energy. And that's going to get me a data frame that just has those two columns in it. Okay, there are two more things I want to show you about data frames. The first one is that if we want to do something like add something to a column in our data frame, Pandas also makes that really easy. So I'm going to say that I want to convert my melting point. So my melting point in my data frame, it is in Kelvin. And maybe I want to get the melting point in degrees Celsius. And to convert a value from Kelvin to Celsius, we subtract 273.15 from it. If we were thinking about how we learned to do that before, you might think to use something called a for loop. So we've used for loops a lot. But Pandas has actually lets us do that a different way. So for Pandas, if we want to subtract, say, 273.15 from every value in a column, then what we do is we take our data frame, then we use our square brackets, and then we get our melting point column, which I would have to scroll up and look at what my column names were. So I'm going to tell it to get my melting point column. And then if I want to subtract 273 from every value in that melting point column, I just write a minus, and then I write 273.15. And so this lets us subtract a number from every value in our data frame without writing a for loop. And then it's going to give me every value. It's going to print that out for me. So the next really special thing that I like is that if I want to save that, so let's say I did this calculation and I want to save that in a new column in my data frame, then what I'll need to do is I can create a new column in my data frame so I'll just go down and do this again. So I'm going to create a new column and I type my data frame name. Then I put square brackets, and then I'm going to put my new column name. So I'm going to call it melting point C for degrees Celsius. So this is if I want to save that in my data frame. And then I'll set it equal to periodic and then melting point minus 273.15. And that's going to save it as a new column in my data frame. And then I can use that head function that I learned to look. And then if I go here and I scroll to the very end, I'm going to see my new column that I calculated. So now I have my melting point in degrees Celsius instead of just in Kelvin. You can also do this. You can subtract, say, two columns from each other. So if I wanted to, for some reason, subtract the melting point from the boiling point, I could do periodic and then boiling point minus periodic melting point. I could save that also. So you can subtract single values from columns of data, or you can subtract or add or multiply columns to each other. So I think that's really nice because there's a lot of functionality built into Pandas that will actually let us avoid writing for loops. So if you're using Pandas and you really know what you're doing, you're going to almost never have to write a for loop, which I know some people aren't big fans of them. So I actually like that about Pandas. Okay, one more thing that I think is really cool is that Pandas also lets you query the data. So for example, if I want to find all of the elements where melting point is greater than 100, I can do periodic and then use a function called query. And then I'll use parentheses, and then in those parentheses, I type in quotes what my query is. So if I want to find melting point greater than 100, I can type data frame periodic query, and then my column name, and then I'll type greater than 100. And then that's going to give me all of my elements that have a melting point that is greater than 100, which you'll see down here at the bottom. It tells me that that is 96. So I think that is pretty cool. I like being able to query the data frame like that. I think that's pretty neat. Yep, it's data frame name dot query, and then in quotes you can type your column name and then like greater than 100, or you know, if you wanted to know something else, you could type it there. And you can save this. So I could save this as a I'm actually going to save this as a variable, because the next thing I'm going to do is show you how to save new files. I'm going to call this one greater 100, and then I'm going to run it again, and then I won't see the output. But if you do sort of analysis using pandas on your data frame, so maybe you created a new column, or here we have a new data frame. So here I just created a new data frame by setting it equal to my query. We can actually use pandas to also save files. So I am going to, you know, maybe I've done some calculations with this and I want to save it. So if I want to save a new CSV file, then I type the name of the data frame, and then a dot, and then I type to CSV, and then in quotations I put the name of the file I want to save it as, and I'll just say what do I want to call this one? Calculations.csv. So you can, this is just going to be the name of the output file. And then also you'll notice over here on the side, it has these numbers in bold. Those are your row numbers. It's also called your index, and pandas will write that for you unless you tell it not to. So I'm going to tell it not to by saying index equals false, because I just don't feel like I need those numbers on the side. It would be okay if you forgot to put that, but here's periodic to CSV, and then I said index equals false. And then if I go back out and look, I have my new data. Well, I have a file that has all of my information, and it's hard to see, but this last, we have this, you'll have data for this column that you calculated. And I'll show this query because I realized maybe I moved on from that too fast. Wait, where's the, oh, there it is. You can still see it. So if I did something like a query and saved it, I could save this file also. So I could save this in a new file. So this is a, since I set it equal, that's a new data frame, and I can use my toCSV function. And I can give it a name like boiling point 100, just something descriptive. Yes, so for the query function, you can use greater than, greater than or equal to, less than, equals, equals. So those are going to work for, and those work with numbers, like our columns that have numbers. If you want to find, say if you wanted to search the electron configuration for everything that had HE, there's a different way. Well, actually, let me try. That's a good question. No, I think there's a different way to do it for, I might have to look it up. Let me try and see. I don't know if this will work. No. Yeah, so there's a different way to do it if you're looking for words, and we're not quite going over it. We're not going to go over it in this workshop, but I think that we might cover it in some of our online lesson material. But yes, for query, you can use greater than, less than, equal to. Yeah, it is cool. I like it. We can do multiple query statements in here. So we could do something like periodic.query, and I could say melting point, let me just make something up, greater than 100, and boiling point less than, I don't know if that makes any sense. But you can also combine your query statements. One thing to know about this query is that it works best if your column names do not have spaces in them. So this is another, if they have spaces, you have to use a special character to allow spaces. So if you do programming, you'll run into this in computer science. Like, spaces are really hard for the computer to deal with sometimes. So that's one reason why we always tell you not to put spaces in your file names. But query works best if your column names are all one word. Okay, so that is everything that I wanted to show you with Pandas today. There is a lot more with Pandas, actually, that you can do. It is a very powerful library, and it's used a lot in data science and for data processing and data cleaning. And if you come to our Fundamentals of Deep Learning workshop, they'll use Pandas data frames and NumPy arrays in that workshop. So for machine learning and deep learning, Pandas and NumPy are really important.